Okay. Let us get down to business. The first thing I would like you to do is take whatever your writing utensil is and make, in the top left corner of your sheet, a square that is 3 by 3. I don't care. That's why I said whatever your writing utensil is. Before we go any further in this unit, you must be aware of two things. One, the red line, okay, the outline equals perimeter. Perimeter means the distance around. All right? Cool? All right. The inside equals area, which is the space it takes up. Okay? Now, perimeter is a distance, so it is one dimension. And this is what I mean by that. If I take this perimeter line, which I have done in red, can I draw it in one straight line? Yeah. Yes. There's one side of it. There's the second side of it. There's the third side of it. And there's the fourth side of it. So the perimeter equaled 12. Does everybody remember that from grade 6 or whenever you did it? Yeah. All right. Does everybody remember, or I shouldn't say remember, because I bet your grade 6 teacher didn't go into this part of it. Does everybody understand what I mean when I say it is one-dimensional? Yeah. Yes. This only has a length. Does everyone understand? Yeah. All right. Area is 2 dimensions. Why?
Because of the...
Can I represent this area in only one direction?
No, you can't.
No.
You gotta,
I have to do a length and a width, or a height and a base. Everybody cool? All right. Now, math guys noticed. We're going to draw another one. We're going to use red again. Now I want you to draw a rectangle that is 3 by 4. And label the sides. 3, 4. 3, 4. And then tell me what the perimeter is. Do not tell me a single number. Tell me how you know what the perimeter is. James? You went 4 plus 4 plus 3 plus 3. Now you guys aren't stupid. Would math guys ever write that? No. What would they write?
4 times 6.
2 times 4 plus 3. Oops. 2 times 3, wouldn't they? Does this idea of math work here? Would it work on every rectangle? Is every rectangle in the universe the same? No. So that makes the side lengths of rectangles something that can change, yes? What do we call it in math when it's something that can change? A variable. So you will notice that 2 times 4 and 2 times 3 will give me this perimeter, won't it? But you also must recognize that 2 times a variable, which we use as length, plus 2 times width, will always give me a perimeter. You guys should have seen that in the 5th or 6th grade. Yes? All right. Now, math guys made a decision. L equals length, which equals the long side. W equals width, which equals the short side. That's a decision math guys made, no matter what. Okay? Everybody with me? Cool in the gang. Now, what then is the area of this? And again, don't tell me what it is. Tell me how you know how much space is taken up inside. Karina. Of course it's 3 times 4. But what you really did was you said there's 4 there, and then you did 4 and 4. Now your grade 6 math teacher told you it's length times width, didn't she? Or he? Right? That's wonderful, except of course, by the time you get to the 9th, 10th, and 11th grades, for some strange reason, that is lost on you people. So I like to show you why it works in hopes that the length times width part sticks. You would never write that, would you? What would a math guy write? 3 times 4. And then smart math guys noticed, hey, wait a minute! There's a 3 and there's a 4. So they said length times width gave me my area. None of that is news to anyone, is it? Okay. Now let's start. If you truly understand perimeter and area, which I am believing that you do, I'm going to now show you where they came up with all the rest of them. Okay? Everybody draw that same old 3 by 4. 3 by 4. Except this time, cut that bad boy in half. Everybody understand? Okay. What shape did I just make when I cut it in half? A triangle. Excellent. So, what was the area of the rectangle? Was length times width, which was 3 times 4, which was 12. What did the red line do to that area? Cut it in half. So what math was done to get the area of this triangle? I took a rectangle and I divided it in half. Yes?
Yeah.
Now the area of a rectangle we know is length times width, and then we divided it in 2. That's what we did. But unfortunately for us, people can't envision this as being half a rectangle. They think that a triangle has to be going up. So they call this base and height now. So instead of LW, we change it to base times height divided by 2. And we also write it as 1/2 times base times height. Now you guys are smart kids. If it works in math once, how often does it work? Always. So with this perfect rectangle, it's real easy to see why a triangle's area is 1/2 base times height. Because it's half a rectangle, no matter what. Does everybody understand? Excellent. Now, you should have a little bit of space left at the bottom, yeah? Great. On the far left, put a red dot and make our 4 there. Okay? Everybody cool?
Yeah.
Excellent. Now, go up 3, but move over 1. And then make 4. And then connect the dots.
Yeah, that.
We'll talk about it in a minute. It's not important yet what its name is.
It's just a
What's its area? Well, it looks like a rectangle, doesn't it?
yes.
And a rectangle would be length times width, wouldn't it?
Yeah.
Right? Everyone agree?
Yeah.
Okay. So let's check. Well, it gets pretty easy. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 whole squares in there, yeah? And then there's all these little half squares, right? So if we counted them up, what would we get?
12.
We would, of course, get 12, correct?
Yes.
Now, math guys, back in the day, didn't have formulas. That's what they did. They did experiments. And they noticed if they shifted this guy and they added in this triangle and this triangle and did some subtraction, they got the same area. Which meant that if an area of a rectangle is length times width, oops, I should have been doing that in blue because I've been doing area in blue. If area of a rectangle is length times width, and the area of a parallelogram, which is its name, happens to be base times height, because they're the same thing. Now here's the mistake you guys are going to make this year. Where is the height? When you measure your height, you measure straight up, yes? This is the height.
Oh, yeah, I know.
It is not the diagonal.
I remember now.
So, does base and height work with perimeter? No. Base and height only works with area because the perimeter has changed, hasn't it? Is everybody cool? Yeah? Everyone's good? Everyone can handle this?
Are you allowed to still use length times width if like it was inflation, but not change it? Like,
Well, no, because technically this is the width,
yeah.
right? Everybody cool? Everyone's good? All right. So, now we can go into our notes. You've got that graph paper. We're going to come back and use it again. Please do not lose that piece of paper. It will have uses for us later on. First page of your notes is blank because it says we are going to review area and perimeter. You're going to be drawing again, okay? You want to be on the first page that has, no, the page that actually says review. The page that says, in funky font, review of area and perimeter. That's where you want to be. Okay? The graph paper tells you why. The very first page after the outline that says review of area and perimeter. The graph paper tells you why. This page is where we're going to write them out, okay? But we're going to get a little funky, okay?
Like the font.
First, we will start with a basic rectangle. Where's W? It's on the side. Why do you know the side is W, Karina? Because the width is the short side. There's the L. Now, what is the formula for perimeter? P equals? Kid. Just wrote it down. Say it, how? What's the perimeter? Is scary? Yes, you are going to get it wrong because perimeter... But Tasha, you're going to get it wrong because perimeter isn't width times length.
Why does it matter? It's any numbers.
But Tasha, perimeter is around the outside. We just wrote that down. So it can't be width times length. It's adding.
It's length times width, is it not? No, it's length times plus width times length.
No.
So it's like two lengths. Add all the
2 lengths plus 2 widths. It's not length times length. That's length squared. Okay? Now, the area, Tasha, is length times width or width times length. Order doesn't matter because it's multiplying. This order doesn't matter either. This is just what math guys say. Does it matter what those numbers are? No. On the graph paper we just did, it was nice and easy. We used 3 and 4, didn't we?
Yeah.
What if it was 3.7 and 4.8? Could you still do the math?
Yeah.
What would you have to use? Your calculator. But the numbers are right there, aren't they?
Yeah.
Everybody Gouda?
As cheese.
Excellent. Now, let's move on to a triangle. What do we call the bottom of a triangle? The base. Where does the height live?
Straight up.
Straight up the middle. And the area is base times height divided by 2. Correct? I could also write that as 1/2 base times height. Now, do all triangles fit this example of what a triangle is?
Well, no, actually.
Of course not. Isn't this a triangle?
Yeah.
So where would the base be? And where would the height be?
That's straight up line.
So can I still follow the same rules?
Yeah.
Great. What about this kind of triangle?
Yeah, I knew. Yeah, I knew.
Where would the base be? Where would the height be? Right here in the middle.
Oh, it's just on the highest point.
Yes. Can I rotate the triangle?
Yes.
What would you say is the base there?
The longest side.
And what would you say is the height?
The one on the floor, like that. Yeah, there.
Is everybody with me?
Yes.
Once you know the base and the height, can you then go back into the formula? Yes. Is everybody good? Okay. Now, when we do triangles, there's something that you got to remember from the 8th grade. And you've already done this year with me. Where's the base?
Bottom.
Bottom. Where's the height?
In the middle.
Right? If the base equals 6, and this side, I'm not going to make it 6, sorry. The base equals 8, and this side equals 5. Do you remember how to find H? We did this a long time ago this year. This is Pythagoras. We need to remember Pythagoras. So what I actually have is this. H, 5. What is this? 4. Because the whole thing was 8. So this is 4. Do we remember that?
Yes.
Then, of course, we would do Pythagoras. 5 squared minus 4 squared gets me H squared. Why is that confusing? Because H is also what we use for hypotenuse, isn't it?
Yeah.
But in this case, I want the height. 5 squared, 25, minus 16 gets me H squared. 9 gets me H squared. What then is my height? Square root 3. Now do you have an H and a B? So now can you go back to the formula? Yeah? Everyone is good?
Yeah.
Okay. That is all. Sorry. That's everything I just wrote. That, ladies and gentlemen, for grade 9 is all the straight-edged figures that you need to know. If you can do triangles, Pythagoras, rectangles, and parallelograms, squares are just rectangles that are all the same size, then you're okay. We'll get to circles in a minute. We're going to start with this for now. Now, wait a moment. Are there other shapes?
Yeah.
Yes. For example, does this shape exist? That's a hexagon. Let's pretend all these sides are the same. What is a hexagon really?
Square. Two triangles. Six triangles.
6 triangles. Do you know how to find the area of one triangle?
Yes.
So do you know how to find the area of a hexagon?
Yes.
Why?
Because if you find one triangle, you're able to find all of them. They're all the same because they're the exact.
Right. So isn't this, when they're all the same, 6 areas of a triangle?
Yeah.
What is area of a triangle? 1/2 base times height, yeah? Where is base times height in this? Where's the base?
Bottom.
Base, where's the height?
Middle.
Right in the middle. So what's 6 times 1/2?
6 times 3.
So isn't 3 base times height from here the hexagon? Does everybody see how this works?
Yes.
All of geometry is based on basic shapes that we stack together. If you know one triangle and add it 6 times or multiply it by 6, do you have a new shape?
Yeah.
You do, don't you? So in grade 9, the hardest thing we do is we take one shape. Cool?
Yeah.
And we add another shape to it.
Oh, you know that.
We then erase that and ask you to find the area.
Yeah.
But what is that really?
That's a rectangle.
Isn't that just a rectangle, which is length times width, and a triangle, which is 1/2 base times height? And then I add them together to get the whole shape. Does everybody understand?
Yes.
That is all you are going to do in this whole unit. If you can find the area of 4 basic shapes, rectangle, parallelogram, triangle, and a circle, you can do this unit. You have already been taught how to do all the formulas for those by your grade 6 Mrs. Badcrumble. Your grade 9 Mr. Myers has told you why everything works. Your grade 9 Mr. Myers has told you that you can use what you know to build new shapes. So we are all good, aren't we?
All this.
Now you should still have lots of blank space left, yes? Please remember you get no bonus points. Please remember you get no bonus points for prettiness of your drawings. This, a triangle, the hexagon.
We'll draw. Okay.
Okay, stop. Let's fix it. It's easy to fix. Take your pen and draw a roof. Down below it, draw a smiley face, but as a V. Then connect them. Now, put a dot in the middle and connect all the corners to that dot.
It's like a Zelda roofie.
Is everybody good? Mrs. Badcrumble taught you what to do. She probably didn't spend a lot of time on why it worked. Mr. Myers spent a lot of time on why it worked, because you already knew what to do. Now we're going to put it all together. Everybody with me? All right. Now, can I ask you all, please, to grab your graph paper for a moment? Again, you will probably need to turn the page over. Yes, I am indeed recording.
Hello, PGG.
All right. So we're all here, yeah? Everyone agree? Okay. Everybody please draw 3 by 4. Cool? And then, right attached to it, please draw a 2 by 2. Now I want you to do a whole bunch of work with this for me. First, I want you to tell me the red perimeter. The entire red perimeter. everything that's red. Okay. Let's try this. The entire red perimeter. What is it? Only 2 people can tell me this? I should see 20 hands. Omar.
12.
It is 12. Correct? The red perimeter. Everywhere that's red, Karina, I said it on purpose. So that's 3, 6, it's not quite 12. That's the area. Sorry, Tashi, you killed me. What's the perimeter? 14. 4, 8, 11, 14. Cool? Now, what is the blue perimeter? James. 1, 2, 3, 4, 5, 6, 7, 8.
Yeah, right.
Does everybody agree?
Yeah.
What is the perimeter of the entire shape? Is it 22? Because isn't it the red perimeter plus the blue perimeter?
No.
Why?
Because there's no line there because you have.
This line doesn't exist.
It's not real.
So what is the perimeter, which I will write in black, of the whole shape? What was removed from here? 2. So it was 6. What was removed from here?
Oh, yeah.
2. So it's 12. So what was the perimeter of the whole thing? 18. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Were we correct?
Oh.
Did it make perfect sense?
Why is there a 6 over 18?
Oh, sorry, because it was 12 plus 6. Now, it wasn't, the point I'm trying to make, Tasha, is it wasn't 14 and 8. Because once we mashed them together, this part of the perimeter disappeared from both shapes, didn't it? Is everybody cool?
Yeah.
Okay. What is the area of the red rectangle? Now, Tasha.
Huh? Oh, 1 times 12. Wait, no, 12. Oh.
Yeah! 12. What is the area of the blue rectangle? 4. Everybody cool? Okay. So what is then the area of the whole shape?
16.
Now James says it's 16. Now that strikes me as strange, because when we did perimeter, we lost some of the perimeter, didn't we?
Yeah, that's different.
But it's different, isn't it?
Because it was because of the thing.
We didn't lose any area, did we?
Yeah.
Everybody cool? Now, everybody good? So all James did was he took this 12, which he knew, he took this 4, which he knew, and added them together, yes? Now I want you to watch something. I'm going to draw the same thing here. That's the same thing, yeah?
Yeah.
Now I'm going to add in a dotted line. Does everyone see the dots? They're a little hard to see. I'm sorry. The light bulb is bad. What is the area of the entire figure with the dotted lines? Wouldn't it be 6 times 3? Yeah. But this part isn't there, is it? Yeah, no, just wait. I said, what would the area of the entire figure be, yeah? What is this area in here? 2. So isn't the black area 18 minus 2?
Yep.
Which doesn't that get me 16?
Yes.
So does everybody now see there are 2 ways to get areas of weird shapes? Because this shape doesn't have a name, does it? It's a rectangle and a square. It's not a square angle. It's not a rectare. It doesn't have a name, does it? So you could have found one angle and another angle and added it, right? Which is real easy. Or you could have made a shape that you wanted and subtracted what wasn't there.
You could have made a square.
Does everybody see that?
Yes.
Okay? It is important to me that you recognize both of those things work. Because the mistake all math teachers make is we give you super easy examples that you can do in your head, and then we give you questions that look the same, except instead of this being 3, we tell you it's 3.14. And instead of this being 6, we tell you it's 6.28. And then all of a sudden you're like, I don't know how to do it.
Anyways, continue.
But I understand what you're saying. It seems difficult, yeah? But really, when you look at the easy stuff, it's not. Everybody cool? Now, we are not going to talk about circles today. Visit!
He said no circle talk, buddy.
We are sticking exclusively with angular figures today. Visit! Stop! Now, excuse me, go back into your notes. You guys have blank space now, yeah? The last thing I want to do that's note-taking is this. Draw one of these. Okay? Now, what's the area of that figure? Isn't it? I'm going to name him 1 and I'm going to name him 2. Isn't this area the area of 1 plus the area of 2? What is the area of this guy? You don't know, so what do we give it? That's W, and what's that? L. Then what's this? W2, because it can't be the same W. And what's this? L what? 2. So what's area 1? LW. Plus what's area 2? L2W2. Is everybody good? Now, would it matter what these shapes were? No, because all we do is we would use our formula and add them together. Now, isn't this shape also this shape, the area of the full rectangle minus the area of the little rectangle? Isn't it? Everybody cool with that? So let's figure that out. What's the area of the whole rectangle? W, which we know. What's this? L and L2. L plus L2. Minus, what's this distance? It's W minus W2 times what? L2.
I did it.
Do you have any idea how difficult that is? Because how can I make it easy for you? This is 3. This is 5. this is 4, or, sorry, this is 2, and this is 1. Now, can you do that in your sleep?
Yes.
Either way, can't you? What is LW over here? 5 times 3, which is what?
25. 15, sorry.
15. Plus, what's L2 times W2? 2 times 1, which is 2. What's 15 plus 2? 17. Now, what is the whole big area? Well, it's W times L1 plus L2. So W was what?
17.
W was 3. L is 5 plus 2 is... What's 5 plus 2?
7.
What's 3 times 7? What's 3 times 7? 21, right? And this one, what's W? 3 minus what's W2? 1. And what's L2? 2. What's 3 minus 1? 2. What's 2 times 2? 4. What's 21 minus 4? 17.
Oh, can I make a comment?
Of course you may.
You see L2 and W2?
Yeah.
You said that was a square. That means that that's wrong because it can't be...
Yeah, go away.
Rectangles confirmed.
The point I'm trying to make, regardless of James Kozloff's toboggan over there, is there's more than one way to solve these. And this, if I wrote that out in a math class, how many of you would be slightly scared by that? All of you put your hand up. How many of you were scared once I put numbers in?
What is? Well, I have to understand what you said.
Once we had numbers, was this scary? No. Right? Now, let me ask you this. What if I gave you this distance and told you this was 2? Would you know how long this was?
Yeah.
How?
Because width is telling you what that is.
Width was 3. There's 2 of it. So what's this?
1.
1. Picking up what I'm putting down? What if I told you this whole bottom was 7?
Yeah. That would make...
Could you then tell me what L2 was?
Yeah.
How?
Because length is
5 of it is there. What's left?
the 2.
2. Does everyone see what you can do with this stuff? Even unknowns are what?
No.
Known. Okay?
Mine.
Even stuff that's not written on the page, you know. Is everybody good? All right. Your job tonight, when you turn your page over and you see the Blush Bear font, is to do everything on that sheet, the first, until you get to these 2. You do not do trapezoids. They are not part of grade 9 anymore. Turn to the next page. After the trapezoids, what do you see? Circles. What are we not doing today? Of course we're not in pi. We'll get fat. Okay, we're not doing anything with circles yet.
But diameter. The radius.
Now, I need to call your attention to a few rules about geometry that you may or may not remember. What does this symbol mean?
That's on the other side. So like
Everything with that line is the same. So if this is 8, what's this?
8.
8.
The top is 12.
Okay?
No.
There's no top.
What does this symbol mean?
Not 90-degree angle.
90 degrees. Okay?
That's why there's a 90-degree angle there.
And there's another one there. Yeah, obviously if one side's 90, that automatically makes the other side 90. What?
What is 90?
What?
You say it's 90.
90 degrees. If it's 90 degrees, what does that mean we're allowed to do on this giant blue triangle? Starts with a P, ends with an S, has Pythagora in the middle of it.
I can't speak English.
Pythagoras. What would you be allowed to do with this little, with this little green triangle?
Triangle line.
Isn't that a 90 degree? So what would you be allowed to do with the little triangle as well? Pythagoras again. What do you see here?
Two triangles. And it's the exact same.
Two triangles. Parts of them are the same. Do you see a 90 degree thing there?
Yes. No, wow.
No.
But it has to be 90.
No, it doesn't. You have that does not have to be 90 degrees. This could be 1 degree off and 1 degree off. I'm going to make your lives easy.
Okay, I was like, are you sure something like that?
You can draw that in.
I was like, that is pretty sure 90 degrees. Something like there's
No, because what makes it 90 degrees on a piece of paper, James? That symbol. If I draw this,
And adding that symbol would be.
is that a 90 degree angle?
Yeah.
Yes, it is. For the purposes of math, that is 90 degrees.
Then how about the question up there is
Mara, can I go to what?
In a moment.
Okay.
Everything else, you're good to go.
We got Mara.
So, only up to the circles and no trapezoids. Go.